What do vaccinations, differential equations, and your addiction to chocolate all have in common? We're going to talk about that and so much more on today's episode of Short Stories of Bacteria. Hey everybody, welcome back to another episode of Short Stories of Bacteria. I, as always, am your host, Dr. K, and I'm here to guide you through yet another episode chronicling the lives of the tiny and infamous, and that would be, of course, the incredible and amazing and wondrous bacteria, and of course, all associated microbial life. Thank you so much for tuning in for another episode, guys. I have a really cool story. It's talking about chocolate. It's talking about math. It's talking about viruses and vaccinations. We're going to jump into all of that in just a second. But first, don't forget to hit that like, share, subscribe button if you're listening to this podcast on YouTube. If you're on Spotify or if you're on Apple Podcasts, don't forget to hit that follow button. Really supports the channel, and I really, really appreciate it. But enough of that nonsense. Let us jump into the actual science that we are talking about this day. Now, I guess the best way to set context for this is to talk a little bit about chocolate. And it turns out there's some pretty interesting statistics about chocolate and how passionate the world and the United States in particular is about chocolate. So as it turns out, the global industry of chocolate there's a whole bunch of money tied up in this. It exceeds 100 billion. And to be precise, that's 127.9 billion in US dollars. That is a lot of money that is poured into a specific industry around a very, very specific type of food. That's so much money. Now, we in the United States love chocolate. It is our favorite type of candy, if you can consider chocolate a candy. That's a debate for another day. But we in the United States love chocolate. It's our very favorite. And it's also very popular around the world. In places like Switzerland, this is a mind-blowing statistic for me. In Switzerland, the average person clocks in over 20 pounds of chocolate per year. That's a lot of chocolate. Now, to be fair to the Swiss, I haven't measured exactly how much chocolate I consume over the course of a year. So maybe I am also in the average of 20 pounds of chocolate per year. Maybe the average amount that the American consumes is more than the average amount that the Swiss consumes, but be that as it may, that's a lot of chocolate to consume in a year. And it's indicative of just how excited people are about chocolate. People really, really love chocolate. That's our first point. Now, a little bit of background of how we go about making chocolate. You may not know this, but chocolate is actually a product of fermentation, right? We associate fermentation with things like kombucha or with beer or under these drinks or something like this. But also, right, chocolate is produced via fermentation. So you have these cacao beans, which are derived from the cacao tree, right? And the amount of fermentation that you do of these cacao beans dictates the taste and the flavor profile of that chocolate. Right, so this is one reason why, depending on where you're getting your cacao beans, right, that'll have or the amount of fermentation of those cacao beans, that can dictate specific flavor profiles of chocolate. So that's really, really cool. So chocolate's being produced by fermentation. Now, hopefully everyone is in agreement with this next statement. All good chocolate is derived from the cacao tree. Right? There's sometimes, I have no idea if this is actually possible, but in theory, I'm sure you could synthesize chocolate in a lab. But in my opinion, the best type of chocolate comes from cacao that is derived from the cacao tree. So that's very, very good. Now, what you also might not know, and this blew my mind when I learned about this, about 50% of the cacao, those cacao beans that we've been talking about, they come from cacao trees in the West African regions, in parts of West Africa. And we're talking about places like the Ivory Coast. We're talking about places like Ghana, right? So all these cacao beans are coming, or at least 50%, are coming from this one localized area. Now, that means that you and I and a whole bunch of people in Switzerland and a whole bunch of people around the world really owe a lot to these locations, to these parts of Africa, in order to feed our chocolate addiction, because so much of the cacao comes from these locations. Now, what would happen if, for some reason, something came along and then started killing all the cacao trees in Ghana? That would be horrible. It would be very, very sad. Not only, when we'll talk about a couple of reasons why that would be horrible. And it's at this point I want to introduce something called the cacao swollen shoot virus, also known as CSSV. CSSV, the cacao swollen shoot virus. Now, the cacao swollen shoot virus, CSSV, does exactly what it sounds like. It causes these swollen shoots in the base of the cacao tree. Eventually, it just ends up killing the tree outright. So it's extremely deadly for cacao trees, and as such, it's extremely deadly for the production of cacao beans. So that's not really good. Now, due to changes in the climate and all these other different factors, recently CSSV has been changing a little bit of where it's located, and also has been been a little more prevalent, right? And so what that's doing then is that's threatening all of the cacao trees in these regions of Western Africa, right? And as such, that is threatening the world's supply of chocolate, right? And also, more importantly, honestly, the livelihood of the farmers that are using the cacao trees as their own livelihood, right? So it's a really, really big deal, and we need to, this is the next point, we really need to find new ways of protecting these cacao trees, not only for us, but also for these farmers. And so we have to have a way of stopping these CSSV viruses. Now, so the fundamental question that we have here is, how do you go about saving the world from CSSV? Now, there's a group out of the University of, from the University of Texas in Arlington. Obviously, the people in the University of Texas in Arlington are extremely passionate about chocolate, and as such, they are trying to save the world from CSSV. And what they're trying to do is they're trying to figure out, is there a way that you could save the majority of cacao trees and the majority of cacao tree plants, the livelihood of these farmers, and the worldwide chocolate industry? Now, you could be asking yourself, you'd be like, well, gee, Dr. K, I'm very smart. In fact, I know a little bit about vaccination because we talked about vaccination in the podcast at some point or another. Wouldn't it be possible for us to come up with a sweet, sweet vaccine that could protect that could protect cacao trees from CSSV? And that way we could fight off CSSV, and then we could get our chocolates, and it'd be all very good. That'd be pretty great, right? Yes. Now that's a very, very good point. And it turns out there actually are already some functional vaccines that are doing just fine to inoculate cacao trees from CSSV virus. The problem with this is that these vaccines, the CSSV vaccines, they're really, really expensive to make, right? And since they're super expensive to make, it's difficult for a group of farmers in Western Africa to obtain these vaccines, especially if you're in an area that is less economically advantaged. Now, so that's a big point. The vaccines are expensive to make, and so it's really difficult for farmers in less economically advantaged areas to gain access to those vaccines. So that's a big problem. So now what do we do? So what the researchers over at the University of Texas in Arlington did is they thought to themselves, well, gee, what if we just used a little bit of math as a way of trying to, instead of trying to vaccinate an entire group of trees, right? Maybe we could just vaccinate a series of specific trees, right? Trying to minimize the way that CSSV is transmitting. So what their game plan was this. So it turns out that the bugs that transmit this CSSV virus, they don't actually travel really, really far. And so what their thought was is, instead of vaccinating all these trees, what if we just made a little tree wall and vaccinated all the trees in the tree wall, and then that would protect all of the vulnerable, weaker trees in the center. And so what they did is they came with this really wild mathematical model, and the result of this mathematical model was they surrounded weaker trees that are more susceptible to virus attack. Those ones were kept in the center, and then they had stronger, more resistant trees that were additionally vaccinated as a way, and they were surrounding the weaker trees. And so what that did is that protected all of the trees all together, and it required less resources. And as a result, it's a lot more feasible for folks in like Ghana or the Ivory Coast to use this as a way of protecting the overall production of cacao. Now, as we look forward, it's important to note this hasn't actually been put into effect yet, so it's not quite sure how well this will work. But it is important to note that it's a really, really great idea by those folks over at the University of Texas in Arlington. And if we could put this into place, it could very well save the welfare of the farmers, in addition to the welfare of the chocolate and the welfare of chocolate addictions around the world. So let's wrap this up. So first point, people really, really love chocolate. It's a multi-billion-dollar industry in the world. Point number two, we owe a whole lot to folks in places in Western Africa because they produce over 50% of the total amount of cacao beans in the world. Point number 3, we need new ways of protecting cacao trees because of the influx and increase of this virus CSSV that causes these swollen shoots. Point number 4, these vaccines are really, really expensive to make and as such are difficult for folks to obtain, especially in areas that are less economically advantaged. And finally, point number 5, these folks at the University of Texas in Arlington made these neat mathematical models that protected the trees, the total amount of trees, and requiring less resources by simply vaccinating the stronger trees on the exterior of an orchard of cacao trees. So very, very cool stuff. Really, really neat paper and really, really neat conversation about how we can use maths as a way of protecting whole populations from virus attack. It's important to remember that viruses don't just attack us. They don't just attack bacteria. They attack our plants and our trees and all these different things too. And so it becomes really, really important to understand how they attack and importantly, how to beat them. But that is enough. That's enough of that for today. Thank you so much, every single one of you guys, for tuning in with me today, and I hope I will see you guys again next week on another episode of Short Stories of Bacteria.